Hey, now we're trying to find the area between two curves, and the curves we have are y equals x squared and y equals negative x squared plus 4. So we could graph them possibly to determine that and figure out where they intersect. We could make a table to try and figure it out. But we'll be effective in just saying the two equations equal to each other to see where they intersect. So the equations are y equals x squared and y equals negative x squared plus 4x. So I'm going to set the two functions equal to each other. X squared will be equal to negative x squared plus 4x. Looks like a quadratic, so I'm going to pull everything to one side. So it'll look like 2x squared minus 4x equals 0. I can factor out a 2x and have 2x times x minus 2 equals 0. So the two answers I get are x equals 0 and x equals 2. So these are 2 points where the lines touch each other, or where they intersect. So when I write out my integration, it will go from 0 to 2. But I still need to figure out, let me leave some extra room there. I might want to write here. It'll go from 0 to 2. But I still need to figure out which one's on top, and if I haven't graphed it yet, I can still do something besides graph it. I can pick a point between 0 and 2, and the easiest point would be 1, and plug them in and see which one is higher. So y of 1 for the x squared would just be 1. So it has a height of 1 in this midpoint. For the other one, the negative x squared plus 4x, when I plug in 1, it looks like I get 3. So what that tells me is the second equation is on top. So this is the top one, negative x squared plus 4x, and the regular x squared is the bottom. So when I write my integration function to find the area, it'll be from 0 to 2 of negative x squared plus 4x. Okay, that's the top one. Minus the x squared for the bottom one, dx. Let me go ahead and graph this to see what it looks like the best I can. So in this case, we know they intersected at 0 and 2, so 1, 2. So the first function there, the x squared, will look something like this as far as the parabola goes. Sorry, my hand's a little shaky on that side. And then the other one, the negative x squared plus 4x, it has a point of 1, 3. So 1, 2, 3. And then up here is the 4 where that thing's touching. It actually kind of goes upside down right there. So I believe it goes down like this. It's supposed to be an upside down parabola. I'm just not very good at the freehand with the writing tablet. So this is the negative x squared plus 4x, the top one, and the other one is just the x squared. And what we're claiming is this region in between here. So that's the picture that we got. So let's go back to the integration. So we've got integration from 0 to 2 of negative x squared plus 4x, that's the top blue line, minus x squared, that's the bottom red line. So let me just kind of emphasize that a little bit stronger in the color. Alright, so I can do a little bit of cleanup before I do this. It'll still be from 0 to 2, but I have some like terms. I can make it negative 2x squared plus 4x dx. So I do the integration. X squared will go up to x cubed. I'll divide by 3, so it'll be negative 2/3 x cubed. X will go up to x squared, and I'll divide by 2, so it'll be plus 2x squared from 0 to 2. So when I evaluate this, I'll have negative 2/3 times plugging in the 2 times 8, and it'll be plus 2 times plugging in the 2, 4. And then when I do the second one, it's going to be negative 2/3 times 0 plus 2 times 0. So that whole second part just wipes itself out. So then cleaning this up, I don't know why this thing is doing that. I'll have negative 16 thirds plus 8, which if I make common denominator, 8 would be 24 thirds. So it looks like I will get an area of 8 thirds. So almost 3 units captured in that spot that I shaded in. So just making sure you've got the right functions on top and the right endpoints, and you're most of the way there. The calculus is not hard, it's just setting it up. All right, thank you.